Hey guys, we are going to do section 3.1, the whole concept of chapter 3 is going to be proving triangles congruent, okay? So the first thing we have to talk about is what congruent figures are. So I want you guys to think about, again, if you were a child, this would be easier if you could see me. If you were a child and you had one of those things where you had to fit the shapes like in as a puzzle, that's exactly what congruent is, right? The star fits in the star, the heart fits in the heart, and it's going to fit exactly side for side, angle for angle. That's what a congruent figure is. It fits on top of it. So now I want to draw your attention to a triangle. So a triangle actually has 6 parts, okay? I want you guys to think about that. So triangle ABC would have angle A, angle B, and angle C. That's 3 angles. And then it has side AB, side BC, and side AC. So it has 3 angles and 3 sides. If we were to say that triangle ABC is congruent to triangle FED, it means that angle A fits with angle F. Angle B fits with angle E, and angle C fits with angle D. Now, again, I'm going to draw your attention over to this congruent statement that they wrote. Copy, paste. Okay, let's draw your attention to this congruent statement. This congruent statement tells me everything. It's like a key on a map, okay? It's telling you that angle A fits on angle F. Because the A is first and the F is first, it's telling you which angle fits on which angle. And then it says that angle B fits on angle E because B is second and E is second. And then lastly, angle C would fit on angle D. So it actually tells you which angles line up. The same holds true with the sides. AB, because they're the first 2 letters, fit on FE. BC fits on ED. And then last, AC fits on FD. So you can see which sides and angles match up. Even if we did not have this picture, all we need is this, and we're able to picture that, you know, A belongs to F. We can picture this, so that's super important. Okay, you guys are gonna start seeing this double arrow, okay? You're used to seeing the single arrow, like if, you know, blah, 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 then, and you see this arrow kind of pointing over there. We did it with the chain of reasoning a lot, you know, A implies B, or if A, then B. So the arrow kind of means then. All that double arrow means is that it is reversible, okay? It is reversible, so when you see that double arrow. So congruent triangles means that all pairs of corresponding parts are congruent. So again, you can do that backwards. So if all pairs of corresponding angles are congruent, then you have congruent triangles. Same thing with congruent polygons. Polygons just means multiple sides, so maybe a quadrilateral or pentagon. Next, so let's talk about reflection. So here's my reflection property that we're going to be talking about. So if I were to actually take this triangle, KIT, that triangle, this pink triangle, and I were to reflect it, if you remember from, I think, 7th grade is when reflections come in. If we were to reflect it across this line, this angle I would flip over here and become this angle E. We're reflecting it, okay? This side, KI, would flip over here to this side, KE. So you guys kind of get my drift there. So if you label everything, you have angle I reflects to angle E, angle 1 reflects to angle 2, angle 3 reflects to 4, KI reflects to KE, IT reflects to ET, but it's like, well, wait a minute, I thought she said there are 3 pairs of angles and 3 pairs of sides. Where's the last side? Well, KT reflects to KT, to itself, because it is the line of reflection. So KT is both on the left triangle and KT belongs to the right triangle. So that segment belongs to both triangles, okay? That is called the reflexive property. Any segment or angle can be congruent to itself. So if I asked you guys to list all of the sides and angles that are congruent, you would put angle I is congruent to angle E, again, because you reflected it. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. KI is congruent to KE. IT is congruent to ET, and then you're like, well, wait a minute, you can say KT is congruent to KT, and that right there is the reflexive property. Any segment is congruent to itself, okay? The same holds true for angles. So if they were to tell you that these triangles were congruent to each other, so again, there are two triangles here. I have this blue triangle, and I have this pink triangle. If you notice, they both share angle Q, okay? Angle Q is congruent to angle Q because of the reflexive property. Any angle is congruent to itself. Any angle is congruent to itself, okay? They gave you an example of a rotation, so this was actually rotated, so they show you, you know, which points line up with which points, okay? So it shows you angle 1 at H rotates and lands on top of angle 2. It's just, again, instead of a slide or a translation, they're showing you a rotation. So this could be what it looks like. Okay, so let's take a look at our first example. M and N are midpoints. Okay, so again, I see double midpoint. And when I see double midpoint, I'm thinking division property in my head. They're telling me that DC is congruent to AB. So why don't I put those in the same color so I know those are congruent. So those are congruent. And I know M is a midpoint, which makes that congruent to that, and N is a midpoint, which makes that congruent to that. So if segments are congruent, then they're like divisions are congruent. Perfect. Next, it's telling me that AB is also congruent to DB, so that's also congruent. They're telling me angle 1, right here, is congruent to angle 4, and angle 2 is congruent to angle 3. Okay, and again, if you want to give those hypothetical numbers, pretend those are 30 degrees, and pretend these are 10 degrees. Doesn't matter. Why is angle ADC congruent to angle ABC? Well, angle ADC would be 40. I added together 10 and 30. And angle ABC would be 10 plus 30, which is also 40. So because I'm adding, A would be the addition property. Why is CM congruent to AN? Again, we already have those tick marks there, and we did that because of the division property. If entire segments are congruent to each other, then they're like divisions. This midpoint, like divisions, are congruent to each other. Okay, so why is BD congruent to DB? And that is right here. Okay, I crossed those off. And that is the transitive property. And you guys, I would practice writing an if-then. So I would say if two segments are congruent to the same segment, then they are congruent to each other. And then the last one is why is DC congruent to DB? Okay, why is DC congruent to DB? So this one on top congruent to this one on the bottom. Okay. Oh, I did transitive property. Wrong one. I did D right here. So D is the transitive property. I was wondering, I'm like, wait a minute. That is if two segments are congruent to the same segment, then they are congruent to each other. And then I skipped C. So BD congruent to DB. So why is this segment congruent to itself? And that is what we just learned, reflection property. Very early. I haven't had coffee yet. Okay, so get comfortable with these properties. We're going to do example 2 in class today, and I hope you enjoyed the video.